Okay, so we're on calculation of heat changes, and the first question says aluminum metal is commonly used to determine the temperature of different portions of a Bunsen burner flame. Calculate the heat required to completely melt a 0.325 gram piece of aluminum wire beginning at room temperature of 22.5 degrees Celsius. The melting point of aluminum is 660.3 degrees C, and its heat of fusion is 398 joules per gram. Okay, so since we're undergoing a phase change and a temperature change, there are actually two steps in this practice problem. So a temperature change is going to involve Q equals MC delta T. Okay? They told us that the mass was 0.325 grams. And your specific heat of aluminum metal is 0.9 joules per gram times degrees C. And your temperature change is 660.3 minus 22.5 degrees Celsius, because this is always T final minus T initial, okay? I personally would round after you do this step. So if you multiply everything through, you're going to end up wanting 3 sig figs. So I got 187 joules. Agree with me on that? Yeah? Okay. So that was the first part. For the change of state, you're going to end up with Q equals the mass times the heat of fusion. So they gave us the heat of fusion in the problem. That's the wrong symbol, isn't it? Yeah? Okay. They gave us the heat of fusion as 398 joules per gram. And then your mass is 0.325 grams. So these will cancel. I'm going to have 3 sig figs from that step. I got 129 joules. We all agree? Okay. So what you have to do is you have to add Q1 and Q2 together. And that's how you're going to get the overall heat required. I got 316 when I added those two together. Okay? Okay, so that was the first problem. The second problem, you've got a piece of iron metal initially at room temperature of 21.5 degrees Celsius. It's left on the window ledge in the lab on a sunny day. It absorbs 862.4 joules of heat and it warms to 32.5 degrees Celsius. What is the mass of the iron? Okay, so for this one, you're just doing Q equals MC delta T. And they told you that it absorbed 862.4 joules. That's your Q. That's positive because it was endothermic, it was absorbing it. The mass is what we're solving for, so we're going to leave the mass in the equation. Your specific heat capacity is in a table. It's 0.448 joules per gram times degrees Celsius. And then your change in temperature is going to be the final minus the initial, 32.5 minus 21.5. Okay, you're going to rearrange and you're going to solve, divide both sides by these two. You're going to end up getting a mass of 175 grams. Okay? Okay. For the third problem, we've got a 75.45 gram sample of silicon. It's initially at 20.5 degrees Celsius. It absorbs 1326 joules of heat. What's the final temp of the sample? Okay, so for this problem, you're going to end up using Q equals mc delta T, but since they want the final temperature, you want to write it out like this. And you're going to substitute everything in. So you've got 1326 joules, which is your heat or your Q, and then 75.45 grams is your mass. And then your specific heat is 0.703 joules per grams times degrees Celsius. Leave T final in there, and your initial temperature was 20.5 degrees C. What I suggest you do is divide both sides by these two numbers here. I'm just going to leave the units out for simplicity purposes. Whatever you get here, you're going to end up equals T final minus 20.5. Then add 20.5 to whatever you get for this quantity. Add 20.5 to it. And that's how you get your T final, which is going to be 45.5 degrees Celsius. Okay? Okay. Now, question number 4. Is kind of lengthy. Okay? Question number 4 says calculate the heat required to change 55 grams of an ice cube at negative 15 degrees Celsius into steam at 125 degrees Celsius. Yes, there are 5 different Q values. Okay? So what I would do is your first Q value is going to be mc delta T. This is 55 grams times 2.09, because you have ice, so that would be your heat capacity for ice. And then it's 0 minus a negative 15 degrees Celsius. You're going to end up getting 1724 joules for Q1. Q2, that's going to be the heat of fusion, because this is a phase change, times the mass. So this is going to end up being 334 joules per gram times 55 grams. You'll end up getting 18,370 joules. Q3, you're going to go from 0 to 100 degrees Celsius because you're heating the liquid. So this is 55 grams times 4.184 joules per grams times degrees Celsius. That's the specific heat of liquid water. Final temperature is 100. Initial temperature is 0 degrees Celsius. You're going to end up with 22,990 joules for Q3. And then for Q4, the heat of vaporization times the mass. This is going to end up being 2250 joules per gram times 55 grams. And this is 123,750 joules. Then finally, Q5, mc delta T. This is your 55 grams of vapor times 2.01 joules per grams times degrees Celsius. Specific heat of water vapor. Final temp is 125. Initial temp is 100 degrees C. You're going to end up with 2764 joules. And then the total, you have to add Q1 through Q5. You're going to end up getting 170 kilojoules. I just converted to kilojoules. Okay?